are focused on taking the incident IO platform from something that just helps you try and respond to an incident, so it helps you run your process.
That complexity means you have either done a lot of work in building very task-specific multi-agent systems.
So you can sit there in your incident channel and you go, hey, what's actually going on here? Can you have a look at some graphs? And it will go trawl through your Grafana setup and pull you out screenshots of the graphs that it thinks are most appropriate. And then it will go, actually, by the way, this incident in the past was something that looked very much like this. And in this case, you did this.
You're collecting all of this data, right, for an individual customer. You're building that index per customer, I would imagine, because it will be unique to that customer.
We quite fundamentally believe that path to a successful AI product like this is one that integrates directly into your product.
Hey everyone, and thanks for tuning in to another episode of The Chief AI Officer. Today, I'm excited to bring you Lawrence Jones, who is the product engineer at Incident.io. Lawrence, thanks so much for coming on the show.
Well, thanks for having me, Ben.
Yeah, I'm jealous. You have a much more professional background than me. Love it. Joining from London. Can you tell everyone your background a little bit and then what you're up to at Incident before we go into the interview?
Yeah, sure. I'm calling in from Incident's London office. So we have an office over here with about 60, 70 people here. Most of our product engineering division is over in London. So I've been at Incident for the last 4 and a bit years. I joined when it was just myself and the 3 founders. I was the first engineering hire, so founding engineer. That meant for the last 4 and a bit years, I've been building out a ton of the product that you'd see now if you looked at Incident. So I led the creation of the on-call product, so the thing that will actually page people when something goes wrong. I've helped build out status pages. So this is in use by customers like OpenAI now to communicate when they have outages. So if you ever hook up to their status page, that's the Incident IO system that's powering it. But most recently, for the past year and a half, maybe, I've been heading up AI at Incident, so leading the AI efforts, which for us at the moment are focused on taking the Incident IO platform from something that just helps you try and respond to an incident, so it helps you run your process, to a tool that can actually sit there and tackle an incident like SRE in your company may do when they're first paged. So this is building out AI systems that can look at the alert. It can go trawl through all of your metrics, logs, traces, look at everything you've done before in the past, and then come up with we think it's this. And by the way, I've actually raised the PR. Here it is. This is what I think a fix would be for this incident, with the goal to eventually, in the next year or so, see a large proportion of the incidents that we have on our platform being autonomously resolved by our AI SRE product.
Nice. Yeah, we've a lot to dig into there that I would love to have specifics around. Obviously you've gone from kind of management or monitoring to this AI product, which you're more agentic, a bit more autonomous in terms of reasoning over the incidents that you're finding in people's systems. You mentioned a phased implementation where it sounds like right now you're surfacing the incident and maybe the suggested response, but it's not immediately taking action, but that is the end goal eventually. You mentioned autonomy specifically, so I'd love to hear your take on that set of phases and the comfort that you see as someone leading, product and engineering there with autonomy and agentic, just generally, how capable is it?
Yeah, so we've done quite a bit of work over the last few years using the generative AI technology at Incident. But I think we've gone through quite a journey in trying to figure out how to use it that has moved along with how the technology has progressed itself. So if anyone listening is familiar with incident response in general, a huge part of good incident response is sending updates and making sure that you're providing summaries to people and communicating when you need to. One of our first forays was actually, I think maybe 2 years ago now, which was very basically just using LLMs to try and summarize what's going on so that we could take some of the heavy lifting from people. That was not agentic in any shape or form. It's basically just one-shot LLM prompts trying to figure out what the summaries are. But especially as the models have improved and the technology has actually got a lot better, mostly over the last year, we've been looking at much, much, much more complexity. And our ambition on what we can do has increased proportionally with what the technology has enabled. So we've gone from just providing summaries to now having pretty sophisticated natural language chatbots that can help drive the investigation forward. So you can sit there in your incident channel and you go, hey, what's actually going on here? Can you have a look at some graphs? And it will go trawl through your Grafana setup and pull you out screenshots of the graphs that it thinks are most appropriate. And then it will go, actually, by the way, this incident in the past was something that looked very much like this. And in this case, you did this. And we use the chatbot that is sat on top of all these systems is using a lot of the same systems that the autonomous investigation agent that we built is using. So this is the agent that starts whenever we first get a page and starts running through all of these different checks, crunching thousands of GitHub PRs, looking in your Slack workspace for relevant messages, and then eventually saying, hey, this is what our understanding is at the moment. And if you had no idea where to go, here are all the breadcrumbs, and this is what I would do next. And in some cases, actually drafting a PR fix for you or telling you exactly what to do to try and fix the thing. That stuff is extremely agentic. And while we still have some of the single shot prompts in our system, gradually as we level up our sophistication, more stuff is moving towards what you consider to be more sophisticated AI systems now.
Yeah, even more that I want to dig into there. A couple things, right? So again, right now it still feels like very much human in the loop, agentic systems surfacing all of these insights, really augmenting the person that is then in charge of making the decision, fixing the issues. So I'd love to hear you talk through your decision framework around at what stage do you start giving more autonomy? What is the level of accuracy you're comfortable with or your customers are comfortable with? And on the other side, that complexity means you have either done a lot of work in building very task-specific multi-agent systems with orchestrators and things like that. And potentially also, a lot of people I speak to more recently have done a lot of work on knowledge graphs in terms of building the ontologies of their domains to make these systems useful and provide all of the context. How are you approaching some of those issues to improve the reliability of these systems, the utility of them when they're serving as assistants? And then when do you feel comfortable taking the next step?
Yeah, so I think this is always the framework that you're always using about how much you can automate. It always incorporates the risk and the potential downside if something goes wrong. And I think at the moment, I'm quite comfortable saying that there is no product on the market that is as comprehensive and as reliable in this space that people are fully automating the remediation. And if there is, I'd like to know about it. It's not one that I'm aware of. In all honesty, when we're speaking with customers at the moment, the thing that customers want is they want a couple of things. When they have an incident and something is actually going wrong, they want an AI assistant or an AI agent to be walking them through and assisting them. So we look at it as very much human in the loop, and we're not really trying to remove the human entirely, at least not when you have an incident where there is actually something going on and you need to do other things like communicate to customers and things like that. And in those situations, what we're trying to do is help that person find the root cause really, really quickly. And then any of I call it busy work, but for example, drafting a pull request that will actually fix the code, not really busy work. It's something that you would have to do as part of an incident, but we can do that much faster than a human can. So it's potentially the case, and we've got a demo of how this worked from our recent Sub-Zero conference, where we did a live demo of the product on stage. And I think it takes about 3 minutes from your phone first beeping to us going here is a pull request. Now, the nice thing about this is we've actually gone and drafted all the code for you, and we've done all this analysis. But at least in an incident context, you don't actually need to try and resolve this yourself to have a huge amount of value to people. That just the fact that you've actually drafted the pull request and got it all up in front of people means now, instead of them having to debug, triage, understand what's going on, get the IDE out and actually write the code, it's all just there, and then they can just review it and press a button. And that is kind of so much of the value prop along the way that people at the moment are more than happy with the idea of having something like that. Honestly, most engineers don't know that these tools exist, and it's still very, very new to them. There is one other space that we are actively looking into, which is the idea of whilst during an incident when you have something that's actually going wrong, people don't typically want you to be modifying your production systems, really. One much more interesting space that people are amenable to is the idea of AI triaging whether or not you should even get woken up. So our platform is extremely human focused and wants to alleviate lots of the pain of being on call from people. And one of the most compelling value props that we could have is if we can put like a layer in front of you and potentially a very messy, chaotic, noisy alert system and go, don't worry, we're actually going to like reduce a lot of the noise from here by looking at everything that you've done in the past, basing our decision on whether or not you've actually responded to these things and if they've actually been problems, and then hopefully making someone's life a lot easier and reducing the number of times we wake them up at night. So I think for us, it's mostly we really want to reduce the number of times that we wake you up at night. And we want to ensure that if we ever do, we have something there that makes it just super easy for you to press a button and there you go, it's all done. But actually autonomously taking a load of actions in production systems isn't at the moment something that we're looking at, but perhaps in a year or two, that would be where we go.
Yeah, it makes complete sense that the amount of value that you're creating already is there. So why try to go the extra mile and potentially introduce a ton of complication when it might even make some of the people uncomfortable at this stage?
Yeah.
You mentioned adoption and, that engineers, a lot of incident response teams might not even know these tools exist. How are you approaching that? Like, what is your sense of their appetite for these things? What makes them reluctant to adopt a tool like this?
So honestly, I think that it is only around about like the last month and like going into the next few months that we're about to see products appear on the market that I think are really valuable in this space. Everyone is trying to build them at the moment, and we've had customers in early access for a very long time, but like the amount of the more sophisticated analysis that we're doing in the later versions of this investigation agent is something that we're still bringing out to customers in the early access group at the moment. I think the thing that, in answer to your question of how much appetite there is actually a huge amount of appetite. I think it is extremely compelling and in a very obvious way to anyone that has been paged or on an on-call rotor, that if you have something that come in and check every single dashboard immediately at the start of the incident and go, this is the one you need to be looking at, that's something that they want and like can save a huge amount of pain both for the company because it vastly reduces the downtime, but also for the person who's on call. So there's such a mutual alignment of value prop here that actually, in terms of appetite for the product, it's huge. The things that you actually get as pushback against tools like this are, and rightly so, the amount of trust that people have in the systems. So we have to think really carefully about a lot of the aspects of our system we end up measuring and evaluating on precision and recall. And we have to balance those two metrics really, really tightly. If you have a system that will barely ever find or suggest, like, this is the root cause, then that's not very valuable. But if you have a system that suggests the root cause for every incident, but it's wrong 50% of the time, then no one's going to pay any attention to it. And like, I buy that. And honestly, as well, SREs and people closer to infrastructure, I know I used to be a principal SRE at GoCardless. They tend to be extremely skeptical of new tech like this. They are hardcore AI holdouts in like many different companies for loads of what I think are really good reasons. So I think part of the challenge for us is making sure that the system that we're building is so trustworthy that it wins over even those people who are like, oh, wait, no, I don't use AI for this. It's AI slop. Like, why would I ever introduce that to my infrastructure? And we are making progress with that. Like, I think we have quite a few SRE teams comment to us going, oh my God, your AI tools are so much better than I've ever used before. Like the incident summaries and updates are way more comprehensive and I haven't even seen it hallucinate yet. And honestly, that comes from a lot of the work that our AI team are doing on evals, on structuring this stuff in the right way and breaking out all the prompts so that they get more reliable outcomes, and everything that goes into building that system is making the difference.
Yeah, it's so true that the engineers that are the most familiar with deterministic systems and all of these operations and how they work are probably the most reluctant to adopt a probabilistic system because it's so antithetical to like a programmatic or like deterministic mindset in terms of fixing problems and like the reliability 100%. That comes with that. But at the end of the day, like very, very powerful for a lot of the reasons that you described, right? And that balance between precision and recall is something I think a lot of teams in a lot of different domains are trying to find, like where that balance is for them and their customers. Is it different? How different is it building systems like this versus more traditional software engineering?
Yeah, so I think like the truth is very different. And like I've spoken with a ton of different companies who are doing this. And there's a pattern that has kind of emerged from all those conversations, which is lots of companies have tried racing onto how do we build with AI? How do we make this stuff work? Because with the tech becoming much more commoditized and people seeing the potential, I think everyone is in a bit of a gold rush trying to leverage it in their industry. So what they do is they end up taking a collection of engineers from their company and they end up throwing them at the problem. And usually they're the engineers that they've previously historically thrown at very hard product problems or technical ones. And in quite a lot of situations, they end up stalling out because what happens is those engineers like just don't get along with the work at all. It's like the non-deterministic nature of those systems makes it much more frustrating to work with than normal software. So people who are really used to the dopamine hit of just shipping products find that very frustrating. And then if you have people who maybe deal much better with the slow kind of evaluation cycle, say ML engineers, they turn up and they find it a bit more difficult because actually it's not just ML, it's like a lot more like kind of systems programming. So there's a big mix in the middle. And what we've actually ended up finding is like the persona of the people who work on the team is really, really important. You need someone who is really methodically able to analytically think about a problem. And you need the team to be able to have like pretty in-depth conversations about what in some cases can be really subjective things like prompt engineering at the moment. I saw an AI researcher talking about this the other day, saying how it makes them quite disconcerted that there are some people who are just very clearly much better at writing prompts than other people. And they can't quite explain why they are, but and no one else can either. So there is still like very much an art and an intuition that you need to build to work with these systems properly. And the way that I've been trying to frame this to people is, I mean, given the background that I have in SRE and trying to hire for SRE teams, which is notoriously difficult, it is very much something that I would see as a different type of discipline. And in much the same way that if you take all of your product team and all of your engineers, you wouldn't naturally just pick anyone randomly and throw them into an SRE discipline and expect that it would be fine. You probably shouldn't be doing that for AI engineering either, just because it is a very different type of process and flow.
Yeah, I would imagine that there's also very different skill sets across building out those systems, from the people potentially designing prompts to the people thinking much more about infrastructure, orchestration, evaluation. Like all of those things is a very different mindset. I know even, I'm in no way an engineer, but even just personally, like my own experience of building out some of these, I mean, it is amazing, the ability to like be able to start generating like small pieces of software on my own computer and like Python. And I often find it is the people that are the most curious, like the most analytical kind of problem solvers that are willing to kind of push something to its limits and find out where that jagged frontier of intelligence, or however you want to call it, where that is, are the people that are most successful in kind of building with these systems.
Yeah,
have you found that pushing the current models to their utmost limit, hitting that frontier, and then tabling something and coming back to it 6 months later when you might be able to throw a different model at it and solve the problem? Like, is that a process that you've been undertaking over the last few years as well? Or like, how are you thinking about, what do you prioritize in terms of the capabilities that you build in product while still keeping an eye towards the long-term vision of what you could achieve?
Yeah, I mean, if the like in terms of the question of have we hit what we thought was a limit and then came back 6 months later and tried it and it's just worked, like the answer is yes, and that happens like routinely, honestly. In fact, when you're trying to debug these things, often some of the advice that I would give is in order to try and figure out why a prompt might not be behaving the way that you would expect it to, the last thing you want to do is change things linearly. So what you want to do is, assuming that this is a constraint type of problem, if you have a situation where your prompt is good, so you've written the prompt very well and the data is good, but the model's not smart enough, one of the things that you can do is you just go, well, let's try the most smart model that I have. So let's like try Opus or like some of the OpenAI reasoning models. And that gives you like a cap on, if I take a really smart model with my prompt, like what's happening here. And often that will determine, well, it won't rule out that your prompt isn't very good, but it will determine like if a smart model can't do it, then maybe like you're at the edge of what's possible here, or maybe it's just not working. Equally, you may actually find that if your prompt is written incorrectly or the data is wrong, then you can ask a smarter model to try and tell you about why the thing isn't actually working and find logical inconsistencies and things like that. But it's through this process of trying to achieve a thing, measuring how close to the goal that you are, and then gradually refining and tweaking it, and doing that over honestly many hours. That's how an engineer ends up building the intuition around these systems that allows them to work with them effectively. And then, in terms of the kind of rate of models improving, it's an interesting one because I don't think that anything that we want to do or want to try doing is fundamentally limited by the model capabilities that we have today. Honestly, the vast majority of the problems that we have are piping data around, managing context, and all this stuff can be made easier, and you can reduce the pain of not having fully fledged solutions for these things by having much smarter, much more capable models. But in reality, they are solvable today, and whatever you do to solve them is only going to make it even better when you get the smarter models later. So for the minute anyway, it's mostly constrained on, honestly, how smart can our team be when it comes to building multi-agent systems? How creative can we be? What ideas and techniques can we steal from conventional computer science and other different disciplines that will help us build these systems in a way that makes them smarter than just the models that we're using underneath?
You mentioned the data, right? Having the foundational layer for what is an input into these systems is so critical in terms of getting value, right? I imagine in incident response, at least you're operating within a domain that traditionally has much better structured data than many others. Is that true? Is that a fair assumption? And if not, what are some of the biggest issues you're coming up with as you try to build out these systems with customers that might not have their house in order when it comes to that?
Yeah, so I think the great thing about this is our product allows you to run incidents inside of Slack or inside of MS Teams. And the whole purpose of our product is to act as the coordination layer that helps you document and follow along with what's happening in the incident. So the cool thing about this is that we have probably some of the richest data that you're going to find in most of the companies that are using AI at the moment. We have almost every single command that you ever ran, and we have all the conversations that you are having between people. We've got a product called Scribe, which hooks into your video calls, and we transcribe everything. So we hear everything that people are saying on the calls as well. So we're actually in control of a lot of extremely dense and high value unstructured data. But the great thing about this is that, especially with the models that we have now, it's quite simple and easy to turn those things into very structured data. And that's what we do. All of our incidents are indexed, and we extract various different dimensions of data from them. So we end up pre-processing everything really very carefully. And that's the index that we end up building from that is how we very quickly then, when we see an alert, pull the relevant commands that you need to run, or the relevant dashboards that you need, and all that stuff from your historic incident bank, and do it really, really quickly because we've already pre-indexed it in the background. Same thing goes for all of our integrations. So like every GitHub pull request that you go create against a connected GitHub account, we're going to process that webhook, pull down the code, we'll analyze it, we'll pre-summarize it, and then we'll index that and vectorize it so that we can quickly look through past code changes when we have an incident and go, actually, that one's just been recently merged and it looks very similar to the problem that you're seeing right now. Let's dig into that a bit more and run some further analysis. So yeah, we have a huge wealth of data. The problem here is not like kind of how to get the data, but how to structure it in a way that we can use it sensibly to try and advance the product that we're building, which is this AI SRE tool.
Yeah, and at the risk of maybe going too deep on this, but just because I'd love to stir it out on this.
No, please.
So you're collecting all of this data, right, for an individual customer. You're building that index per customer, I would imagine, because it will be unique to that customer.
Exactly.
There is probably also like a meta index of how these problems happen, like what are typical fixes to it. Like, is that something that you're also building and thinking about? Like, what is the meta ontology of incident response and all of that? And how does that work? Like, how comfortable, this is so much structured, like unstructured data that you're collecting from customers. Are they comfortable that contributing to a meta model, some like training data set? Like, where's the line that you're finding with people? And if that's not something you're doing at all, like, I'd love to understand a bit more how you're thinking about it.
Yeah, so firstly, is not what we're doing. So we don't
Okay.
have any meta model that we're using across customer accounts. That's not something that we do, and it's also just through data regulations that we
Yeah.
adhere to. So GDPR means that we can do that given our
Yeah.
status as a data processor. That said, I'm not sure how useful that would be. And the reason for that is that incidents vary so much between different customers that honestly, it's hard for you to even transfer a lot of that stuff. I've seen incidents from like airlines going bankrupt. That's an incident, and then I've seen like other really silly incidents, like someone's laptop has been stolen. Like, what do we do for employees? So, like that's the gamut of incidents that we see in our system, from big to small to highly technical to actually just operational and process wise.
Okay.
How you actually respond to them is honestly, it's an extremely organizationally rich context problem. And the best way that we've found to be able to build this up from all these organizations' accounts is by indexing all historically how they respond to incidents and ending up combining that together. And it's actually how our investigation system works to tell you what should you do next or where should you go after this. We essentially find all the incidents that you look like the one that you're dealing with along certain dimensions. So is it affecting the same team? Does it look like it might be involving similar systems, or does it look like these are similar symptoms or similar type of error? We pull all of that stuff together, and then we end up passing it through a variety of different prompts to try and identify, given that this was when we last processed them, and these are what those incidents looks like, which things are most relevant to us and what steps look like they were right. And then we go cross-reference them to make sure if someone decided actually in a subsequent incident that you shouldn't probably do that, then you want to erase that and get rid of it. And you end up compiling what becomes an ephemeral runbook for your incident based on how you historically have responded to incidents of this type in the past. And I think the nice thing about this is that most organizations try and write docs for this, right? That you try and policy it. I'm sure there are many people listening right now who are familiar with a huge process chart that people at one point have historically got out at the start of an incident side and went, God, I can't follow this right now, and put to the side. But all that stuff is extremely hard to keep up to date. So hard, in fact, that it almost never is kept up to date. So what this actually becomes is we start giving advice based on organically what you as an organization have built as an immune system for how you respond to incidents. And that immune system organizationally is as unique as you would find in a human body. And that's why you can't meta a lot of this up. What you can do is you can consider, should this be fixed in code, depending on the type of incident that it is. You can have various playbooks for, do you think it's this type of error? Like maybe it's a degradation or slowdown. So we have like a playbook for how you might go ahead and triage and diagnose that issue. But those are extremely generic, and actually like a lot of the value of our product comes from just organically pulling out what you've done in the past rather than trying to predefine it.
I love that response. I also love the comparison to an immune system because it's much more organic, as you said, unique, right?
Yeah.
Tailored to the individual,
Exactly.
their environment, their own particular makeup. And it's a good solution to the problem, not just from a data privacy standpoint, but to your point, right? I've found, so we were trying to, in my last company also, it was like neurosymbolic AI. We were encoding business logic and decision logic within systems. It's often doing that requires the organization to know itself to an extreme degree in terms of like its policies and what it would do to react to an incident. And the other side of that is that most people, there are inconsistencies in their protocols. Like the person in charge of an incident or even just any decision has so much tacit knowledge locked in their brain that is not encoded in any of the documents. And so I think that idea of building up a much more organic understanding of that within an organization based on past decisions is like a very powerful concept. And I think that's something that anyone listening that's thinking about building products, not in the incident space in particular, but just in any space where you're trying to solve a lot of like decisioning choices, it's a very, very good idea to take hold. As you build out these systems, what is your approach towards working with third parties, working with vendors, versus things that you decide to invest a lot in-house? And corollary to that, how do you approach working with particular foundation model providers? Are you fine-tuning things? Are you just like building in a very portable way to swap things out as needed? What's your approach to working with other companies?
So we don't use any vendors or open source libraries for the stuff that we've built. We built it entirely in house. And part of that was through just pragmatism, which was our primary language here is Go. And at the time when we were really starting to get going in earnest, there weren't any Go libraries really for doing any of this stuff. And we quite fundamentally believe that path to a successful AI product like this is one that integrates directly into your product. So the idea of having AI exist as some separate system that kind of like sits pairwise with the product felt like it wasn't going to end up in a good place.
Hmm.
So we also have a load of data privacy concerns, and we tend to try and avoid as much as we can bringing on new sub-processes. So we were very keen to try and just go, look, this is something that we're going to have to do. It's a core competency. We may as well invest. So in terms of open source libraries, we don't use them, but what we have built is a huge suite of tools that help us compile data sets, run backtests, create scorecards against all the AI interactions that we have in our system. And I did a talk at LBX called Becoming AI Engineers for anyone who is interested, where I walked through exactly how the stuff works from inside of our code base, what a prompt looks like, to how we write evals, to how we write scorecards, and all the way up to kind of how we actually backtest things and confirm that changes are good. When it comes to foundational model providers, so we use a mix of models, and we're good friends with a load of the folks over in OpenAI and also Anthropic. So these models, they have different strengths, and like we found that OpenAI's GPT 4.1, for example, is an amazing daily driver model that has like a really good balance of performance, both latency and cost. And then we found that Sonnet and the Claude family of models are exceptionally good at code analysis and have just continuously been a touch ahead of what we've seen in some of the OpenAI models. So we use them for the code analysis side of the stuff that we do, and also the planning for the agentic loop. They like, honestly, Sonnet has just been better than that in the past. I'm excited to try out some more of the GPT-5 stuff and see how that's changed. But yeah, the truth is we work quite a lot with these teams and ask them a bunch of information about what we can do. But the best thing that I think anyone can do if they want to make the best use of these models is make sure that their tools allow them to experiment across many different models in a sensible way. So it's very easy for us to just go, you can find in our debugging tool, you can go, this prompt here, I'd like to try it on a different model, rerun it 5 times against all of these different models, and it'll give you like a big checklist of everything. But even more importantly, like that's kind of on a single prompt basis. But what we can do in our system is, for all of these investigations that we've been running, we can go, for the last week of investigations, we would like to rerun those investigations, but we would like to change these prompts over from using this model to using that model. And then we'll end up with what we call as the backtest, with thousands of investigations in them, where the scorecards are then compared to one another, and you can see either you've gone up or down in the place that you're expecting them to. And that tends to be the way that you want to fight this. Like there's just no point doing it any other way. If one model performs better, you should try and switch over, but you should only do it if you can prove it objectively with the numbers.
Yeah, and I guess always a balance between the performance and the cost and what it might do to your margins as you scale these systems out, right?
Yeah, that absolutely is. And I think people are at varying different degrees with this stuff, right? Like, I think we're still in the stage now where there are a lot of companies who are trying to prove out that what they're doing is even possible. So like, for us at the moment, the margins are less concerning than what is the edge that is possible with all of the AI technology that we're seeing. So you'll find lots of the teams that are building these systems right now are operating with the unlimited budget. So spend whatever you need to try and get there. It's like, it is that urgent a problem to try and solve with the technology that we have, and no one really has an answer on how far can it go right now. So that's why everyone is racing toward it.
And in that race, you mentioned this earlier in the interview in terms of the personas that might be better suited to building these types of systems. But what do you feel is going to separate the exceptional AI engineering teams from others? And how do you build towards improving those capabilities?
So I think like the ideal AI engineering team, it should have, like, on the whole, everyone there should be needs to be in a situation where they're very willing to slow down and think about the things that they're doing. You should try and avoid a situation where you have a very large AI team where you are sharing all the work kind of evenly. I think you want to build a team of people who naturally lean towards wanting ownership of the systems that they build. And the reason for that is a lot of these agentic systems, they're extraordinarily intricate, and there is just simply not enough that we have in the representation of prompt engineering and the tools that we're using at the moment to lock down what one change to one part of the system might do to other parts of the system. So unlike software at the moment, where if you go change something in one place, you've got this type system that will go, no, you've gone and broken this system over there. It's increasingly the case that people are building AI systems where the only person that can really tell you with any type of certainty about what will happen when you change that part is going to be the person that spent 100 hours building this thing and hitting their head against the wall, and they've seen how it's behaved in all those different situations. You can get around this somewhat with guardrails, but honestly, we're going to be set with this for a while. So pick people who really want to own the thing that they're building and want to kind of like perfect it and tweak it and make it amazing. And then lean into this idea that in the team, you have different parts of the system and different people become experts in those parts. I also think that there's so much stuff that's happening in the research end of things that you want a small you want a component of your team. It doesn't need to be everyone, but you need a senior technical component or a collection of people who are very keen to follow the research and like dig into the more technical hard systems challenges. There's also, as you alluded to earlier, there is a lot of like systems engineering that goes into the orchestration of these things and how to run distributed orchestrated agents where they're resilient to failure and like they run performantly and you can observe them and trace them. That's a lot of like SRE / like infrastructure work. So you're going to want people who can build that stuff reliably and build it well, because otherwise your tools are not going to be good enough for the rest of the people in the team to operate these systems and build them. But yeah, I think that those are the two things for me. It's like you need people to be extremely methodical, analytical thinkers, lean and have a default to own and look after the things they're producing. And then you need at least a component of the team who can keep an eye on the research and help pattern match when you're building out new systems to, oh, actually, there's this thing over here that I've seen before that can help us build this.
That's a great summary of where the most valuable skills are. I think it, to some extent, comes down to people that are almost obsessive builders and that want to see like something from end to end, because of just also the rate at which you can build systems with this, right? And of course, there are all the complications at which you mentioned, but I think that's also why this technology has kind of like set the tech world on fire in terms of its potential, right? There's just so many people that look at it open-eyed and think, okay, like no one knows where the limit is of where you can go. And there's all these reliability issues. There's all these technical problems, but ultimately, like, I'm just going to go obsessively build in this one area and I'm probably going to figure it out. And I think it means we're at a very exciting inflection point right now where it's just, yeah, anything can really happen. I could talk about this stuff for hours with you, Lawrence, but we're running up on time. So I want to get to our lightning round quickly. What AI capability surprised you by arriving much faster than expected?
I think the one that was most surprising to me, or the one that came up so rapidly, is honestly, it's like the rise of Claude Code and these coding agents. I think going from people using ChatGPT on occasion to sketch out code versus like what's actually happening, which is like just outside of the engineering team in Incident. And we measure this, and every single one of them are using Claude Code daily to do a huge part of their job. And that change has come about in the last 4 and a bit months, which is crazy to me. I've never seen a change be so ubiquitous and so substantial and happen so quickly in the software engineering industry. And I would not have predicted that the code generation and analysis tools would have come along in the way that they have. Not to that extent, anyway.
I can corroborate that as, again, someone who's not from a technical background. Claude Code is just absolutely insane to me. Like when I'm building some system and I don't even know how to really interact with my terminal or spin up like a virtual environment to deploy some piece of Python, and I just put Claude Code like in the thing and be like, figure this out and execute it. It still blows my mind that I can do that, even for like as mundane a use case as I'm trying to migrate a bunch of blog items from one website to another, and it like lost all of the images, and now like build a system to go find all of those. I mean, it's like there's just like such tiny things like that I like could have taken 15 hours of brute force, and now it's like it took me 5 minutes by just like dumping
it's
Claude Code at
totally
it.
crazy. It really
It's
is.
completely insane. And you're really only limited by like your ability to default to AI and like think about it from that type of perspective versus thinking about it from how you have done it for the last 15 years. In terms of build versus buy for AI infrastructure, you kind of already answered this, but what's your default recommendation?
Yeah, this one's hard. I think you have to. Well, obviously we've gone the build route. That we had constraints and timing situations that meant that made a lot more sense. If I was reviewing it nowadays and saying at this moment in a particular company, should we build it or buy it? I think the answer to this needs to consider how much of this is about to become a core tenet of your strategy. Basically, how much do you back yourself to investing and turning this tooling into something world class without using off the shelf components? If you think that you can do that and you're willing to invest substantially in it, then arguably you might be able to graft this into your system in a way that's much more natural or native than you're going to find with the open source systems. The other angle is how much, if you are picking tools, how much are they churning and how much are they changing? I think kind of like cynically, a lot of the AI agent frameworks that we saw out there, well, they predated us having AI agentic tools and products. So they were by necessity built without the experience of running these things. So like they are going to go through a huge amount of churn and change as people realize that this might not be the API that they want. And if you want to be in control of how you want to do those upgrades versus having to do the upgrade along with the third party tool, that's something that you want to try and consider.
Yeah, very, very good points. What's the most overrated AI trend right now, and what do you think is the most underrated?
I think that the most overrated might be the concept of as in just immediately being like build the whole of the application. Just in terms of like you absolutely can do it, but I think in such an imprecise specification, what you end up with is essentially it's a dice roll on where you might go. And I'd like the idea of you landing there with a thing that you want to use versus just a thing that happened to look like the precision that you asked for. I'm not totally bought into that being a thing. But I think that the underrated AI stuff in the moment is ironically kind of the converse, which is there are tons of very senior, very technical engineers who are looking at these AI systems and going, they don't help me. I know everything with this stuff. Those are the people who are most able to accurately specify exactly what they want these systems to do, and we'll get the most out of them. And often they're the people who are rejecting them to like, I don't want to use them, or I just feel weird about this stuff. And and the industry is changing so fast and the tools are improving so quickly. It's if you've got an opinion that was formed 3 months ago, it's already out of date. So people just need to keep looking out for it.
Yeah, good points. I think the ones who have the experience often, to your point, are also the ones that spend more time fixing something that was like slopped by AI very quickly because they know what's wrong. But there's also just like the sheer pace of someone, again, who defaults to AI, like, and what they can do. But yeah, I like ending on shots fired at Lovable. No, I'm just kidding. But yeah, Lauren, I'm just kidding. My words, not yours. That was a really great conversation. I'm sure our listeners will get a lot out of it. If people want to follow your work and what you do, where should they go?
So we have a microsite on building with AI under the Incident.io domain. If you just search Incident.io building with AI, you'll see a ton of, I think, very high quality technical articles on exactly how we built these systems. I would also recommend, if anyone's interested about AI SRE, we host a Sev0 conference. The one in London is upcoming this month that you can sign up to. But we actually had an SF conference just the other week. We did a demo there live on stage, which was extremely stressful. AI demos live, that was horrible. But it actually went great and shows a load of what the product can do. And then if you ever wanted to just hear how we're building this stuff from like day dot up into all the scorecarding and backtesting, then the LDX3 talk that I did on becoming AI engineers is where you want to go. So yeah.
Great. Well, that was...
Thank you very much for having me.
Yeah, absolutely, Lawrence. For anyone who also, go check out those resources. If you want to reach out to Lawrence himself, just Lawrence Jones, who is product engineer at incident.io. Lawrence, thanks so much for coming on the show.
No, thank you very much. It's been great.